Have you ever wondered how much faster a car could become without adding a single horsepower? Today, manufacturers spend billions developing turbochargers, hybrid systems, and electric motors. But nearly 90 years ago, one French engineer believed there was a far simpler answer. Instead of making the engine stronger, he decided to make the air weaker. His creation was called the Dubonnet Dolphin, and in 1936 it shocked engineers by humiliating a standard Ford V8 during an official high-speed comparison. Using exactly the same engine, the Dolphin reached speeds nearly 30 miles per hour, faster while consuming dramatically less fuel. It looked more like an airplane without wings than a family automobile, complete with a vertical stabilizing fin, enclosed wheels, and a body sculpted entirely around airflow. Yet despite proving that aerodynamics could outperform horsepower, this extraordinary machine almost disappeared from history, leaving behind one of the most fascinating engineering stories of the pre-war era. The man responsible for this remarkable automobile was André Dubonnet, a decorated World War I fighter ace, Grand Prix racing driver, inventor, and aviation enthusiast. Unlike most automobile designers, Dubonnet viewed every mechanical problem through the eyes of a pilot. Aircraft had already demonstrated that carefully controlling airflow could dramatically improve performance without increasing engine power. So he wondered why automobiles ignored the same principles. But aerodynamics wasn't his only passion. During the early 1930s, he invented the revolutionary Dubonnet independent suspension, a self-contained system using enclosed coil springs and hydraulic damping that isolated each front wheel from road shocks. The design was so successful that manufacturers including General Motors, Fiat, Alfa Romeo, Delage, Simca, and Chevrolet later licensed or adapted the concept. Long before building the Dolphin, Dubonnet had already earned a reputation as one of Europe's most original automotive thinkers, constantly searching for ways to improve efficiency through engineering rather than brute force. To transform his ideas into reality, Dubonnet partnered with aerodynamic engineer Jean Andreau, while the elegant aluminum body was handcrafted by the renowned French coach builder Letourneur and Marchand. Every panel of the Dolphin was shaped according to aerodynamic principles rather than fashion. The rounded nose split the airflow cleanly before guiding it along smooth body sides toward a long, tapering tail. Fully enclosed wheels eliminated turbulence around the tires, one of the largest sources of drag on automobiles of the era. Perhaps the most striking feature was the tall vertical fin rising from the rear deck. Many people assume it was added simply to make the car resemble an airplane, but that wasn't its purpose. The fin acted as an aerodynamic stabilizer, helping the Dolphin maintain directional stability at a high speed by reducing the tendency of the rear body to wander in crosswinds. Decades before American cars adopted dramatic tail fins as styling features, Dubonnet had already demonstrated that such a surface could perform a genuine aerodynamic function. The engineering hidden beneath that futuristic body was just as unconventional. Instead of placing the engine under a long hood like almost every contemporary automobile, Dubonnet mounted a 221 cubic inch Ford Flathead V8 behind the passenger compartment. Producing approximately 85 horsepower, the engine itself remained almost completely stock, proving that the project's goal wasn't to showcase mechanical modifications, but to demonstrate what intelligent engineering could accomplish with existing technology. Fresh air reached the rear-mounted V8 through two enormous side-mounted intake ducts feeding the engine compartment, while hot air exited through carefully designed openings that prevented heat from becoming trapped beneath the bodywork. Power flowed through an advanced Total electromagnetic transmission, one of the most sophisticated gearboxes available during the 1930s. Instead of relying on conventional synchronizers, the Total used electrically controlled electromagnetic clutches, allowing remarkably quick and exceptionally smooth gear changes. Combined with a lightweight backbone chassis that split into twin rear members supporting the engine and transmission, the entire layout looked decades ahead of anything then appearing on European roads. The moment that proved André Dubonnet's theories arrived on March 24, 1936, at the famous Montlhéry Autodrome outside Paris. Under the supervision of the Automobile Club de France, the Dolphin faced a standard Ford V8 Type 68, ensuring the comparison would be as fair as possible. Both cars used the same Ford Flathead V8, meaning neither had a horsepower advantage. The only significant difference was the Dolphin's aerodynamic body. What happened next stunned everyone watching. The conventional Ford reached a maximum speed of 80.06 miles per hour, respectable for its day. The streamlined Dolphin, however, continued accelerating until it reached 108.37 miles per hour. Nearly 28 miles per hour faster, achieved without increasing engine output by a single horsepower. It was one of the clearest demonstrations ever recorded that aerodynamic efficiency alone could dramatically improve real-world performance. Dubonnet had proven that the future of speed wasn't necessarily a larger engine. It was a smarter shape. The engineers didn't stop there. Straight-line speed was only part of the experiment. To determine whether the Dolphin was genuinely more efficient, both vehicles completed a controlled fuel consumption test over approximately 121 miles at the same average speed. Once again, the results favored the futuristic prototype. The Dolphin consumed 37.4% less fuel than the conventional Ford, despite matching its pace throughout the entire test. A second endurance evaluation covering roughly 311 miles around the Montlhéry circuit produced another remarkable outcome, with the Dolphin still using 21.9% less fuel. These weren't optimistic factory claims or advertising slogans. They were officially observed tests conducted under controlled conditions. In today's world, manufacturers celebrate fuel savings of 5 or 10%. Dubonnet demonstrated improvements more than 3 times greater almost 90 years ago, simply by understanding how air flows around a moving automobile. It was an engineering lesson the industry would spend decades rediscovering. Yet the Dolphin offered far more than impressive numbers. Its backbone chassis provided exceptional rigidity while keeping weight low, and Dubonnet's patented independent suspension transformed ride quality on rough French roads. Instead of transmitting every bump directly into the cabin through solid axles, each front wheel reacted independently inside its own enclosed suspension housing, reducing vibration while maintaining better tire contact with the road. The rear-mounted engine also lowered mechanical noise inside the passenger compartment, creating a surprisingly refined driving experience. Large curved windows provided outstanding visibility, while the streamlined roof flowed uninterrupted into the tail, making the cabin feel brighter than many luxury sedans of the period. Even the unusual body proportions served practical purposes. The long, tapered rear reduced turbulence, the smooth underbody minimized drag beneath the chassis, and nearly every visible detail existed because engineers could justify it scientifically rather than stylistically. The Dolphin wasn't merely designed to look futuristic. It was engineered to behave differently from every other automobile on the road. The extraordinary performance of the Dolphin quickly attracted international attention, and even Ford Motor Company became interested enough to acquire the prototype for further evaluation. Few independent inventors ever convinced one of the world's largest automobile manufacturers to purchase a single experimental vehicle, making that decision perhaps the greatest compliment André Dubonnet could have received. Unfortunately, mass production never followed. Building such a complex aluminum body required countless hours of skilled craftsmanship, while the sophisticated engineering pushed manufacturing costs far beyond what ordinary buyers could afford during the mid-1930s. Eventually, the prototype disappeared from public view, and today its ultimate fate remains uncertain. Yet its influence survived. Long before aerodynamic testing became standard practice, before rear-engine family cars gained popularity, and before engineers began treating drag reduction as seriously as horsepower, the Dubonnet Dolphin had already shown what was possible. It reminds us that history's greatest innovators aren't always the ones who sell millions of cars. Sometimes they're the ones who quietly prove the future decades before everyone else finally catches up. And if you enjoy discovering forgotten engineering masterpieces, incredible prototypes, and the untold stories behind automotive history, don't forget to subscribe to On Wheels, because some of the world's most brilliant automobiles are also the ones almost nobody remembers today.